Index is a function actually. Here, it is a very different topic altogether. So I'll probably start by saying, if you look at objects in SQL Server database. Okay, so when we talk about objects, first thing which will come to our mind is table, views, function. This is what so far you have learned. And let me do one thing. Let me put this inside this. And this is all part of one database, right? For an example, SQL batch 3. Inside this, we have tables like Superstore. Now, inside Superstore, what do we have? We have columns. Within columns, you will see data type. You will see constraints. Let me make this a little bit. Okay. Now, in constraints, if you go ahead and see, mainly we have primary key and we have foreign key. Okay. So this is the hierarchy generally of any particular table or an object in SQL, right? Now, if you ask me how this data is getting stored, right? If you remember, we showed some architecture, right? There is a query engine and there is a database engine. When you write select statement, it goes back and assign that task to an engine, right? So how do you know that where is your data, which column, which row, in order to do all that thing? So there is something called root node. Node is, think of node like a folder. Okay. So what happens is all the columns, whatever you have stored, there it will create a root node. Inside a root node, there will be a lot of pages. Think of it like a book. When you open a book, you will see a lot of pages, right? Let's call this as page 1. Let's call this as page 2, page 3. Okay. Each of these pages will only store 8 KB of data. Which means in our sample superstore, we have 10,000 records, right? All 10,000 records will not store it in one page. It will divide into 8 KB. Okay, so 10,000 you multiply. Let's assume hypothetically 200 pages. Okay, so every data is available, subset of your data is available in pages. And when you write a query, let's insert some records here. Whenever you write a query, it goes to your root node, and root node will tell you where is this data? Is it in page 1? Is it in page 2, page 3? Wherever it is there, it finds that information, give it back to your SQL query. This is a very basic example of how the data is storing in the backend. Okay. Only thing, it's a very deep topic. I'm trying to jot down to only the things which are very important. Root node is important. Pages are important. And each page can only hold 8 KB of data. You don't have any option to decrease, increase the size and all of that. Okay. Now, how does the root node knows which page I need to go? Okay. Root node is like your brain. How does it know whenever I am writing a select star from superstore where row ID or order ID is greater than 1000? How does it know it has to go to page 1 or page 2? That's where there is something called index table comes in. Index table is nothing but kind of a master table. So this is a mediator. This guy knows everything. So he'll store all that information. Which row ID say which row ID tak this page mein data hai, which column mein what data is, everything. This index table is there. This guy takes care of managing that memory. Okay. Now this concept is clear. Think of
Yes.
table, like a table of contents, right? Like I was talking in some of the sessions about this dictionary, right? When you open a dictionary, it's telephone dictionary. You have thousands of information, phone number, but the table of contents will tell you if you want to find a person with letter A, go from page 1 to page 10. In letter A, city, Bangalore, mein, it will tell 1.1 page. It's a table of contents. That exact thing is stored in the index table. Okay. Now, what we will be talking now is we'll only talk about these two things. Okay. How this entire logic gets created in the index table. Okay. This is nothing. We don't need any more further knowledge on this. Only DBS has to get on it. We are not going to learn anything on DBA part of it. Now, how this entire logic gets created between root node and index table. So we call that as B map tree. B map. Just remember this word. There is nothing else in this word. Imagine a tree, right? पेड़ में क्या रहता है, एक बहुत सा बड़ा सा एक ये रहता है, and then there will be lot of branches. Inside a branch, you will be having lot of leaves, right? Inside a leaf, what will be there? Imagine a tree, apple tree. Okay. पेड़ के अंदर बहुत सारे branches होते हैं. Inside a branch, if you go to one branch, there will be leaves. Inside a leaves, ऐसे veins होते हैं ना. So it's same concept you apply it on the B map tree. B map is a tree. Now inside a tree, we will have first thing is root node. Just for this example, I'll take only two nodes. Okay, these are like, imagine these are two branches. Now what will happen is any record, let's take our employee table as a simple example. Any records between 100 same, both are same only. I'm just giving little bit detail. How does the root node gets created and how does the index table gets created? I'm going to give a detailed explanation of that. Okay. So just let's say, okay, any employee whose salary is less than or equal to 400 will store in this node. Any employee whose salary is greater than equal to 500, for an example, they will store it in this node. Okay. Now inside this, there will be leaf nodes. Okay. Actually, I wanted to show in iPad, but my pencil is not working. So let's say leaf node. Leaf node 1, leaf node 2. Now, what is a leaf node? Like, imagine that same branch I was talking about. When you take one branch in a tree, in that branch, there will be a lot of leaves, right? Why do we need leaf node? Leaf node will do a split of 400. It will create two nodes in leaf. Any employee whose salary is less than equal to 200 will store it in this leaf. Anybody else, which is 300 to 400, will store it in leaf node 2. Okay. Now, same thing here, it will be 500. Anything above 500 will store it in leaf node 2. But this belongs to root node 2. Okay. This belongs to root node 1. Now, within this, there is something called non-leaf node. This is where your actual data is available. How the data will be available? For an example, 101, 102, 103. Likewise, it goes on till 200. Same thing. Hmm. 201 से लेके 400. Okay. Now same concept will be applied for this node, and here it will be example 500, 599, and here 600. Just imagine we have 1000. Okay, till 1000 it will store here. So bold. Okay. Now, when we run a select query, so we are writing example, imagine select star from employee, where employee is the employee table, where salary is equal to 506. This is the query you executed. So what happens is, first thing is, we looked at this root and index table, right? This guy goes to the query engine and find out, okay, this is the query, can you go ahead and run it? Then the query will go to the engine and say, okay, where are my nodes? Root node 1 and root node 2. Is 506 matching to root node 1? No. Then this will get grayed out. Is 506 matching with series root node 2? Yes. Then it will select this node. Then in 506, it will go for the next section, which is leaf node. Leaf node is 506 matching to leaf node 1? Yes. Then it will go to this node. And within this, it will go and find out in non-leaf node how many records we have. 100 records. In that 100 record, imagine the 506 is available here in this position. It gets the record, push it back to your data. So that's how you will get the result. Now, you understand the concept of how the data is getting retrieved, right? Now, there are some ways where you can set up your entire database, entire SQL queries to optimize it in such a way so that whenever you run the query, you get the results in a most efficient way. When we talk about most efficient way, it is not just faster results. It's also about getting that results at a less effort. For an example, you want to go to airport. From here, you want to go to airport. You have multiple options. First thing is you get a cab. That is the easiest way, because right start from your home, this guy will pick up and he'll drop you to the airport. Maybe you have to pay a little bit more. Second is you can get a public transport, but you need to ensure you find a bus stop, get a ticket, and that bus will keep stopping in all the places. Third one is you can also go by walk. So that is the longest one. Okay? It takes a lot of effort. Now, what will happen is, if you don't do anything, just go ahead and create table, add data, leave it as it is. This entire example which I showed, it is not going to work in that way. How it will do is, everything will store it in one node. Everything will be inside one page. Sorry, here. Okay. Now, inside this page, it doesn't know. Example, when you write a query, select star from employee where salary is greater, it doesn't know which page. So it will take some more time to find out by querying all the pages and then get you the results. Now, what will happen in that scenario? First thing is, it is time taking because it has to find all the pages. Second thing is, it is not very good in performance, effort. CPU, memory, it takes a lot of time. So CPU and memory, I hope everybody knows, memory is a RAM, CPU is a processing unit. So it takes more time to consume that power. If you have 8 GB memory, maybe it will take that entire 8 GB depending upon your data. So imagine you have 1 million records. And if you write this query, it doesn't have any logic, which page it has to go. It has to manually find it. Maybe it takes example 5 minutes. Okay. Same thing. Now, if you fine tune your table in this format, in the B map tree format, it may take 5 seconds. Okay. Same example in employee table, we have 1 million records. Okay. Now, if you don't do anything, if you don't do any optimization, that is called as table scan. If you have not done any optimization, no index, nothing, if you have configured, we call that as a table scan. Table scan is simple. It goes to every row, find out if that information is there. No, if wherever it is there, it will get it. This is called as table scan. Now, same example, let's add one more record. Okay, let me add it here. If you can also do it called index scan. What is index scan? This is called as index scan. Why index scan is any beneficial here? Instead of finding information manually from that 1 million, you wrote a query 506. It doesn't even go here. It just goes to this node. Imagine I'm talking about 1 million. So that many root nodes will be there based on the 8 KB pages shelf. It doesn't go to 100 root nodes. It just go to root node, leaf node 1. In leaf node, imagine we have 100 records. So instead of querying 1 million records, it will just query 100 records. In 100 records is much faster compared to 5 million. That's how you can retrieve your data in a faster way. So this is the concept of index. Now clear? This is how index works in SQL. Now index is not built in. I mean, when you create table, it doesn't automatically, it's not intelligent enough. We need to go ahead and tell SQL that, okay, we want to create an index in this format, in this file, in this column. So then only it will do and implement all this in the backend. Okay. So concept is clear. Any doubts now in BMAT tree? You may get very rare. If you get a question, you'll get a question like, what are pages in SQL? Pages are simple. The data gets splitted by number of rows in pages. Each pages will have 8 KB of data. Each pages are grouped inside a root node. Okay. Very rare you will get questions about this root nodes and all. If you are attending some senior level of SQL interview, that is when they will ask. For beginners and all, they will not ask. But it is good for you to know that how this entire concept, because concept is also, I feel it's very easy to understand, right? Now, there are two types of index in SQL Server. First one is called as clustered index. Second one is called as non-clustered index. Okay, there are two types of indexes in SQL. First one is called as clustered index. Second one is called as non-clustered index. So what exactly is a clustered index? Data will simply get sorted in some order and store it in nodes. Which means this entire BMAP concept is same. There is no change in the concept. In clustered index, the moment you create a clustered index, automatically your data will first sort it. Maybe if you are creating a clustered index on row ID, it will sort it in ascending order. Whatever that output it will come, it will take that output and store it in the nodes. Okay, maybe you are querying the select star from employee. Let's say there are 1,000 records. It will sort that employee by employee ID, starting from employee ID 1 to employee ID 1,000. It takes 10 records, put it inside this node. It takes the next 10 records, automatically it creates the node in a specific sorting, either in ascending, descending. Some sorting is defined there. That is called as clustered index. Now, only one clustered index is possible. I'll call it a CA as a short form per table. We cannot create more than one clustered index in a table. We can create only one, not more than one. Now, there are some ways to create the clustered index. Whenever you declare primary key, then automatically one clustered index will create it by itself. You don't have to create it. That's why I was talking about constraints, right? So this is one of the best way to design your table. You created employee and salary table, where employee table ka employee ID we made it as primary key. And in salary table, that employee we made it as foreign key. So that is the benefit of designing a table, because now backend may clustered index will automatically create. Now, if you remember constants, even primary key, we can create only one. Per table, may only one prime. We cannot create more than one. So same concept, we can create only one clustered index per table. Either you manually create it, or if you have declared it as primary key, automatically it gets created. There is no condition key. If you want to create a clustered index, then your table should have a primary key. Nothing like that. Even if your table doesn't have primary key, you can go ahead and create one clustered index. You can choose whichever column you want and you can create a clustered. Now the second one is non-clustered index. Non-clustered indexes you can create unlimited. Okay. And make a note of this point. Creating too many indexes is very bad. Okay. Sometimes people will think, okay, if I create indexes, it will fine tune the performance. No. Sometimes if you create index, even it will reduce the performance. It will even create a loss in productivity. You have to be wise enough to choose which column, whether is it definitely needed, only then. So that I will showcase practically how to choose it. But non-clustered index is simple. What it will do is, instead of storing data in some kind of sorting and all of that, this will create a separate temp table and it will store the metadata. Okay. This clustered index is not creating any separate table and all of that. It will simply sort the data and store it in this BMap tree. But non-clustered index, it will create separate one more table. I mean, one more complexity it is adding. And behind the scenes, it is using some neural network kind of thing, like some kind of joins and all it will use and bring the data. And it consumes some space. Some additional space is required. I mean, if you are working with a table with 1 GB, it doesn't mean it needs another 1 GB. Some space is required. Maybe you can just take 10% of that, like 10 MB, 100 MB. Some space is required. But for clustered index, there is no space required. There is no storage required because it's like built in. Everything is in memory. You don't need anything extra. But here it is slightly, it will create a separate temp table. It stores the metadata. It's consuming space. These 3 points are important. And this will also act as a difference between clustered and non-clustered index. I'll say n number of index, which means you can create n number of index. If you have 10 columns, you can create it. It will allow. But here it will only allow once, not more than once. Okay. Any doubts? Is it somewhere you want me to repeat again in some part of it? This part is clear, how the data is getting stored. Now, in this part, both are same only. The entire logic is same for both clustered and not clustered. Just that these are some of the differences between these two guys. Okay?
Non-cluster also should be give the primary and foreign.
Not required. Even in clustered index, there's no concept of primary key, foreign key. But if you have created primary key, it automatically creates it. There is no limitation on data types also. Key. If it is integer, then you can't create nothing like any data type it is. It's except this one binary or something. I remember in SQL I said you can store image also in a binary format. You can't create an index on binary. Generally binary won't create that table. We don't create integer, float, date, string. All it will support. We'll call this as index. I also have in previous batch, I actually showed this in iPad. So, but let me open that and see. 820. Same concept I'm trying to explain. You can take a look at that root node. 400 का सारा उसके अंदर split होगा leaf node में 200 and 400. All 200 will store it in this leaf node. And whenever you query salary 603, it by default ruled out this one. It will select this root node. This node is ruled out. In this root node, we have two leaf nodes. It will rule out this one because query 603, तो ये तो select ही नहीं करेगा, it will select this, and inside this we have all the data, it will select this record. So here it's only querying 10 records. Instead of querying entire table, it will only query 10 records. It is the same thing, DP. We call it as short form. DP means data pages. Okay. Each pages will have only 8 KB of data. Rest all non-related information. You don't need. I'll share this also. If you want, you can keep it for your reference. Okay. So now this is the theory. Now, whatever we spoke, I'll show it in actual. First thing, what we will do is we'll create scenarios. Scenario 1, I'll call it as S1. No index. Means I'll take one table where there is no index. I'll show you how much time it takes, how many records it has to query and all of that. Scenario 2, we'll create clustered index. And then there is something called EEP, which is execution plan. This will help you to find out the differences. Okay, execution plan is more of like a blueprint. It will tell you in order to run this query, what is the effort needed, how many rows it has to query, all that it will show in the execution plan. We will use execution plan and compare both these tables and find out the difference. Difference when we run the same query without index, difference when we run the same query with the clustered index. Then scenario 3, we will create CI and NCI. CI means clustered index, NCI means non-clustered. Same table may we'll create both the index, clustered and non-clustered. And then using execution plan, we will compare the results. Okay? And scenario 4 may we will keep only NCI. NCI means we'll keep only one non-clustered index, nothing else. Then we will compare that with the clustered index. I'll show you all the scenarios, but the most important one is these two scenarios, where there is a table with no index, with a table which has index. This is most important. So please focus on this scenario. This scenario is fine. I mean, it's up to you if you can take it. If not, you can ignore it. But you can actually see all the results live, practical, whatever is spoke on theoretical. Okay. We'll take a break first and then we will go on the this one. Picture abhi baki hai.
Trailer हो गया.
Trailer ho gaya hai. Okay. So please take a break for 5 minutes. We'll be back by 11:10. Even in both interview plus even if you work in live project, this is the things which you will be doing. In interview questions, everything they'll ask you about select statements. Can you tell me how to write a query for a date between this and this? Okay. Can you write a rank function? Just remind me, we didn't cover rank function yesterday, so we'll cover it today. And can you just tell me what is the total sales? How do you calculate total sales for each segment? So do we need group by or not? What will happen if you don't give group by? Will your query? So everything questions, 90% of your questions, they'll ask you on select statement. But if you go ahead then join as this guy, Tableau guy or a Power BI guy, there also you'll be doing select queries only. Maybe you will write the select query 1 or 2 times. Now rest everything drag and drop in Power BI. Only to extract data, you need to write query. Sometimes even you don't have to write query. You just have to drag that table, superstore table, drag it and create Power Query, may whatever follow, everything is done. Okay.
And the one session from SQL to Power BI transactional.
We'll show that. Okay. In SQL Server Management Studio, we'll go to new query. We'll select our database SQL batch 3. Select star from superstore where OID is greater than equal to 1000. Okay, I'm just writing a simple query. Select star from superstore table where row ID is greater than equal to 1000. Now you got around 9195. We had 10,000 something records. These are the records for this query. Now, how do you, I was talking about execution plan. Execution plan is like a blueprint of this query. How did this query arrive at this result? Go to query, and then you will see there is first option called display estimated execution plan. What is estimated before even it runs this query? It will show you the execution plan. Okay. Now I didn't run the query. All I am doing is click on execution plan, estimate execution plan. This is how the execution plan will show up. Now our query is simple. You are seeing only two boxes. If you're writing inner join and all of that, the number of boxes will increase. How do you read a execution plan? Always you need to read from right hand side to left hand side. Your right hand side to left hand side. Okay. From here to here. Don't read from here to here. Okay. Right to left. And as I said, if I have multiple boxes, top to bottom, right to left. First start from top, then bottom. Right hand side se shuru karo and then go on the left hand from top to bottom. Okay. Now, this is execution plan. This is your query. How do you analyze this information? You can just see the first one. It is saying table scan. Why is it saying table scan? We haven't created any indexes. If you don't create any indexes, the default method is table scan. It goes to every row and find that. Click on that table scan. And when you hover, you'll see all this list in the yellow box. The first one is called as physical operation, which means either it will show table scan or it will show if it is index, it will show what type of index. Second is estimated execution mode. It's row. It goes to row by row, find that information. And then the most important one is estimated operator cost. You will see some number 0.394495. Some number which is required in order to spend some money. Imagine money in this scenario. This much money is needed to go and fetch that information. Okay? That operator cost, there is a split. First one is called as estimated IO cost. IO is nothing but input output. Okay. Input output, if you want to know what exactly is input output, we have like pen drive. Pen drive is a flash drive, SSD. We have hard disks, right? There are different type of storage solution. Pen drive is a flash drive, and in pen drive there are different types of pen drive. You can write 1 GB per second. There are some pen drives you can only write 1 MB per second, because some pen drives are built in with A1 class, means the chip is so good, you can write 1 GB per second. So the pen drive is very expensive. Like if you look at SanDisk, A1 class ka pen drive will cost you 5,000 rupees. Same pen drive will get it for 500 rupees. Only thing is you can write 1 MB per second. Okay? So when you write something, that is called as input. When you read something, that is called as output. That is why it is called as IOPS. So when you learn AWS or any cloud in future, you will hear more about this term IOPS. Even in your laptop, there is a IOPS speed. You definitely have some hard drive or something SSD. That SSD has some capacity called IOPS, input output speed per second. Some SSDs are 100 GB per second. Some SSDs you can write 1 TB per second in AWS. The cost is that. Imagine 1 TB. So there are different types of SSDs. This is simply saying that input output cost is this much, some number 0.38. Estimated subtree cost. We spoke about that BMap tree, that leaf node ke liye whatever cost it is, that is the cost. Then estimated CPU cost. To run this query, how much CPU is needed, iska number hai. Just we don't worry about what is that number. Some number is there. Okay. Estimated number of executions, number of queries you have written. You have written only one query. That's why estimated number of execution is 1. Estimated number of rows to be read. This is the most important metric in execution plan. In order to run this query, you need to read 10,194 records. Total rows. Okay. Estimated number of rows for all execution. If you read all this record, what is the response? Result. The result is 9,194. If I change this query and click on display execution plan. Now select star from superstore where row ID is equal to 1000. Obviously the record is only one row will. Now look at estimated number of rows to be read, 10,194. Estimated number of rows for all execution. What is the output you will get? Only one row. In order to get output of one row, you need to query 10,194 records. That is what it is trying to say. So these two are very important metrics in execution plan. Other metrics, if you don't know, it's fine. But please remember these two. Estimated number of rows to be read means how many rows you need to read. Estimated number of rows for all execution output. उस query को read करने के बाद what is the result you will get? 1. And estimated row size. What is the data size of this entire output? Something 3 MB. We have some 10-15 columns. So what is the size of that? 3 MB. So that's it. Okay. So this is how we can read our backend mein whatever theoretically we explained. This is how we can read it with the help of execution plan. We call it as EB. Now there are two types of execution plan. One is estimated execution plan. Second one is actual execution plan. कुछ नहीं है. The only difference is if you click this one, it will not run the query. It will just show you the execution plan. If you go to the next option, where it is, include actual execution plan. Now, when you execute along with your query, it will one more tab will create. It will first run the query. Along with that, it will also attach a execution. Now, those who have SQL installed, can you go ahead and run this query and see if you can see the execution plan?
But in both the plan execution, the result
Same,
will be the
same. Both
the
are
time
same.
taken and
Everything is same.
the thing is that here one more tab will be
Tab
added.
get added. This is after execution, that is before execution. सेम ही आएगा ना. दोनों एग्जीक्यूशन प्लान सेम है. कुछ बट एग्जीक्यूशन प्लान आ रहा है ना. दैट इज एनफ. ओके. Now, first thing what we need to do, since if you look at our Excel, we want to compare with different scenarios. So if you want to compare with different scenarios, right click on your execution plan. There's an option called save. Something it will just save it in an XML format. Later you can reuse that. क्योंकि same table में once you create a index, then it will no more table scan. So you need to save this. So we'll go ahead and save this execution plan. We'll give this name as table with no index. Okay, save it. Now, first thing is we are going to learn how to create a clustered index. As I said, clustered index, if primary key, automatically it gets created. Now, you'll ask me, sir, how is it getting created automatically? We'll take an example. Remember, we created one employee table in our previous example where employee ID is a primary key. If I go to this folder in this table, we have a lot of folders, right? Columns, keys, constants. There is one more folder called indexes. If I expand, you see here automatically one clustered index is created. The name says below clustered. Okay. That is how whenever you create a primary key, automatically it creates a clustered index. Now let's go to our superstore. Here there is no primary key, and when I expand, let's delete it. There is no index. Okay. Now, how do we create a clustered index? The syntax is create clustered index, name of your index. Generally, as a best practice, any index will give ix, not required. Whatever name you want, you can give whatever name. I'm generally following this principle. Ix is index underscore table name, which is superstore underscore column name. Please remember, all the index are column specific. We cannot create index for table, no? So we create a specific column index.
So in this row ID will be primary key.
Not primary key. We are just creating one clustered index. Row ID is not a primary key.
But why only the row ID we have?
One example I'm showing of that. You can create it for city ID also. You can create it for customer ID, customer name, anything.
Any one should be specified.
Any one should be specified. Only one column at a time. Now, in this example, since the previous query we ran it on row ID, that's why I'm creating one index, which is a clustered index on row ID. Here, name whatever you want, you can give, no matter. Now, create clustered index space, whatever is your name you want to give on. On is nothing but on which table. Always remember, you need to give the schema name, which is DBO dot table name, bracket column name. If your column has space, give it. If your column doesn't have space, directly type the name of it.
And
Okay.
Javed, in all of the previous examples, when you called out schema, no, you did not give that square bracket, particularly. So here, is it really required?
Not required. Not required.
Or we
Even
can
if
still
you
give
don't-
DPO dot superstore
yeah,
without
you
the
can
square
give
bracket.
it DBO dot superstore. See, these brackets now, it's only required when there is a space.
Got it. Yeah, that part I got it. Javed.
Yeah.
So I was
Okay.
just wondering here. Thank you.
Same for this one also. Example, if my table name is super space store, na, then it requires that bracket.
Yeah, got it.
Okay. Now all you have to do is select this statement and click on execute. Make sure whenever you click on execute, which database you want to, please select that one. Okay. I'll click on execute. Commands completed successfully. Now, if I go ahead and refresh index, that same thing you should see it here. IX underscore superstore, it says clustered because we created a clustered index. Okay. Now, what I will do is I'll run the same query. I'll click on include actual execution plan. I think it got disabled. Okay. Now I go to execution plan. Now you see it's no more table scan. It is called as clustered index scan. Now let's read this. We'll only read some important information, which is that estimated number of rows for all execution is only one. In previous scenario, it was 10,000. We need to read only one row. Output is also one. How much of improvement we are showing now, we will compare with the scenario. Now we already saved our execution plan, right? So we will go ahead and compare that execution plan. Right click and there is something called compare show plan. Now I selected table with no index, the one which we just recently created. On the right hand side, it will show up like this. The first thing you need to do is click on the clustered index. And wherever you see this is equal to ke upar bar aake not equal to, it means there is a difference in that metric. Compared to these two plans, there is some difference. And how do you know it? Always remember, first it should show like this. First plan is a clustered index. Second one is a normal table scan. Okay, I selected table scan. It should show like this. Now you are comparing clustered index plan with a table scan. Okay, let's go with the first one. Actual number of rows to be read is 1 here, but here it is 10,194. And then estimated CPU cost 0.001581, and here it is 0.011374. What I will do is I'll copy this number, put it in Excel, and the same number I'll put it over here. Okay. Now let's take a difference of these two is equal to divided by this number 1%, which means in order to run this query, it takes 99% more effort compared to this. You can see it here, it is 0.000. It's 0.011. So it means 99% extra effort is needed. Okay. Now let's go to the next metric. Input output cost. Even over there, you can see at least you can see 10x benefits. 0.003125, but here it is 0.383125. A lot of benefits on the IO cost. And then estimated operator cost also you can see 0.00, but here it is 0.3. Subtree cost also has reduced. I told you, right? Subtree concept is same. Even if you don't create, it is still storing the same, but number of root node, leaf node is not going to optimize. That's why here it is 0.00, but here it is 0.39. Okay. And logical operation. This says it is doing a clustered index seek, and this one is doing a table scan. Now, if you remember, I told clustered index is what? It is nothing but sorting. Where do you see that information? There is something called ordered here. True, which means this table is ordered. Order by we'll use no order, which means sorting. It has sorted this data. Here, ordered is false. Okay. Can all of you go ahead and create a clustered index scan? I'll paste this. Very difficult, huh? एक ही लाइन का कोड लिखना है कि क्रिएट क्लस्टर इंडेक्स स्पेस इंडेक्स नेम, तो उसमें कोई टेंशन लेने बात ही नहीं है. If you have to write some 20 lines of code, it's fine. The reason why I'll tell to write, because how much ever we talk, you'll not remember. But if you write it, at least you'll remember something. ये चैट बॉक्स में हम डाल दिया देखो. हाँ, आपको करना है तो सेव कीजिए, आपको नहीं करना है तो जस्ट क्रिएट ए क्लस्टर्ड इंडेक्स. क्या सलीम, समझ में आया? बोरिंग है, इंटरेस्टिंग?
Interesting is how can make it different.
अभी theory तो समझ में आता है, practical कर.
But that leaf and all, it will only automatically do, no? It's like just for our understanding, you start the next line.
Because you need to understand, no?
Correct.
When you optimize indexing, you should know how leaf nodes and all.
Backend में कौन सा कोड मिलता है सर ये सब? इसके backend में
ये पूरा जो SQL बना है जाके .NET में बना है. This is a system which is designed in 1960s. ये आजकल परसों का बनाया हुआ नहीं है, ये हमारे ancestors ने बनाया है. आज के जमाने में we are not going to use relational database, to be honest. I don't use relational database called Microsoft SQL Server. I use AWS का Redshift. That is like even more optimized. ये वो तो और आप अगर आप ये टफ लग रहा है ना तो वो और टफ है, वो और कॉम्प्लेक्स है वो डेटाबेस. दुनिया में हजारों के डेटाबेस है. मैंगो डीबी करके एक आता है, वो नो सीक्वल डेटाबेस होता है. There is something I was working on. There is one database called Greenplum, one of the world's fastest database on big data. Here we are talking about GBs, right? When you work with any Google-based project, so I was part of one of the Google project. There you get data itself starts with 100 TB.
Mhm.
In your project, all you get is Google guys. No, they have all their data is 100 TB का. 100 TB से कुछ less ही नहीं होता है. अब 100 TB data, how will you query it? 100 TB में कभी लैपटॉप में ही हमने देखा नहीं है. They have a very different types of database. Google BigQuery करके एक आता है. There also you have to write a select statement only. But backend में that database is capable of handling 100 TB. आप लिखो सेलेक्ट स्टार फ्रॉम कुछ टेबल, वो 100 DB क्वेरी करके आपको 5 सेकंड में लाके दे दे। सीक्वल नहीं ला पाए, ये जो सीक्वल सर्वर हम सीख रहे हैं ना, वो नहीं ला पाए। तो दिस डेटाबेस, दिस देयर इज डिफरेंस, बट 99% ऑफ योर प्रोजेक्ट्स विल यूज सीक्वल सर्वर। कौन 100 DB डेटा पे रिपोर्टिंग बनाएगा? वो लेवल तक का तो अभी तक कोई नहीं है। 99% all banking guys, every guy will use SQL only, SQL server.
Javed, I'm sorry to interrupt, but
Yeah.
I'm running into a issue here. Uh, may I share my screen, Javed?
Yeah, go ahead.
Thank you.
It's also using specifying TVs required with support.
Nothing like that.
Do you see the screen, Javed?
Yeah.
Okay. So maybe it's because I was practicing the previous session earlier this morning. When you asked me to, enter this command earlier, it gave me the same error.
Okay.
The conversion failed, and when I tried to convert that alter table and column order ID to integer,
Yeah, it won't convert because order ID is a alphanumeric value, and you are trying to make it as an integer. Integer means it should have only number. If you query our order ID, it is CA-2020. So it's alphabet, special characters, and numeric. But why do you want to change the data type of order ID?
like that's because when I tried to execute this earlier, like as
It
you
will
said,
work, because it's not order ID, it's row ID, where row ID is
oh,
equal to
got it.
1000.
My
Yeah.
bad. Okay, got it, Javed. Sorry, my bad.
No problem. That's okay. Just change it to row ID. I think you should see the results.
Yeah, sure, Javed.
Okay, so we'll move to the next topic. So you saw the difference between that table scan and the clustered index. Now the next thing we'll do is we'll create a non-clustered index. Remember, clustered to ek hi hoga. So if somebody is feeling difficult and don't know how to write a command, you can also right click and create it. It's the same thing. Both options. Both options are available. Okay, but
Show one that was.
you want to show one example. Okay, first I'll do is drop index. I'm just deleting the index because I can't create one more index, right? So whenever you want to delete index, you have to specify the table name, else it will not recognize ki kaun sa index hai. So deleted. Go ahead and refresh. Now you want to create a clustered index with the help of GUI. Right click, new index, clustered index. Now this will ask you on which column. Here you need to select a column. I'll select row ID. Click on
Anyone
OK.
is fine.
Only one only you can create.
Okay.
In clustered, you can't select multiple. Only one only you can create. Here you can give whatever name you want. I'll give ABCD. Click on OK. No. Easy. But you remember I told in the first, SQL is all about writing. It's not about GUI. GUI is easy. You can only learn. You don't need a trainer. But it's all about syntax you have to remember. Because in real world, you will not be using SSMS. Who knows? SSMS तो आपने install कर लिया है. Easily write it. But Tableau Power BI you can't create index and all of that. No? But Tableau end of the day you'll write one select statement. So it is always good to learn how to write a command so that you are not dependent on this tool. Okay. So index is created. Now we want to create a non-clustered index. I'll copy the same query. Only thing you have to add is non.
Delete the.
No. Now non-clustered index will create on different column. Okay. Now I'll create it on product name. We have one column called product name, right? In our sample superstore. No, product name. Sample superstore. Product name. See, this is the product name. Now I'm creating a non-clustered index. Reason is my reporting teams always go and query the data on product names. Now product name is a text. So instead of querying manually without an index, in order to give them better performance output, I will go ahead and create one non-clustered index. What is non-clustered index? Simple. It will take this column, create the root node, leaf node, and some separate table. It will take some space, but वो पूरा optimize करके रख लेगा कि whenever somebody queries called every or every 508, Instead of going to all the pages, it will go and find the relevant page. That is what it will do. Now, how do we create non-clustered index? All you have to do is just add this word non-clustered index, whatever name you want, you give that name. Everything else is same. Instead of row ID, I'll give product. Go ahead and create this statement. Now the commands is completed. Now if you right click and click on refresh, you will see that product name. And you will see this as non-clustered. Okay. Now, what we will do is we'll write one query. Select star from, just copy. Select star from superstore, where product name is equal to some product I'm selecting. Okay. Maybe there is one product called Sony Microvolt. I'm just selecting that. Go ahead and run this, execute. Let's close all the unwanted tables. Now, if you see here, in your execution plan, I said, right, previously we had only 2 boxes. So number of boxes are increasing. You need to, I told right से left पढ़ना है, ठीक है? Top to bottom पढ़ना है. First is your non-clustered index scan कर रहा है. Number of rows for all execution. There are 3 records with this product name, so it is reading only 3 records. And here it is trying to look up that product name, key lookup करके. So you don't have to worry what exactly is key lookup and all of that. Backend it is using some method to find it. It's called as lookup. And here also it is same. Number of rows, estimated number of rows per execution, it is 3. But if you look at number of execution, it is 4. मतलब backend में कुछ 4 query run करेगा वो. Then it will go and get that values. And once these 2 results are done, it performs some kind of inner join. And then it will bring it to your select. Okay, so backend with this is all circus it is doing to get you this result in a much faster and effective way. Okay.
And Javed, I remember you asking us to go from right to left. Now, since the table in that's below has nothing on its left, how do we go about reading it, Javed?
I'll tell you. Top to bottom is like this, and then right to left. So you see this, these 2 tables are joining here. That's why that arrow is also coming in.
Got it.
So read like this.
Okay, got it.
Okay. Now what we will do is, we will go ahead and save this execution plan. And we will call this as table with both index. Okay. Now I will go ahead and delete both of these indexes so that it will become table scan. Now there are no indexes. Okay, this table has nothing. Now same query if I'll run, I'll get one execution plan which is only table scan. Now I'll right click and click on compare. I'll now compare with a table with both. Okay, make sure you select those icons so that you can compare it with each other. Okay. Look at estimated CPU cost. Table scan 0.011, but here 0.000, which means already 10x of benefits. Likewise, estimated number of rows to be read 10,000, but here it's only 3. There's a lot, you cannot even imagine. There's a lot of performance benefits compared to these 2 plans. This is why index is important on your tables. This is one of the most important question. It will be asked like, in order to improve your SQL query performance, what is the technique in order to use for optimization? Simple, create index. What index you will create? I will first go for creating clustered index. So I'll take any one column and whichever is unique in that scenario, I'll create a cluster. If my SQL queries is querying a lot of data on dates, for example, order date, I'll go ahead and create one non-clustered scan-on index. I'll definitely see, just say that I definitely see at least 3 to 4x of improvement in the performance. Your answer is clear for that question. Okay. Only thing you have to use the word index. That is the right answer for that question. The first answer is index. Second answer could be, you can say, what else? If some interviewer is asking like, what else apart from index, what else can we create? Make sure you use the right data types in your table, right? That is also one of the basic best practices. If it is integer, if you're creating as nvarchar, it takes more space, then it takes more time to query. Keep only relevant columns in your tables. Why do you need 50 columns? If you're doing reporting on example, order date, shipment date, and order ID, why do you need customer ID and customer name if you're not using it for report? Third is, remember we did data normalization. Everything एक ही table में store करने के बजाय, we'll only keep customer ID. We'll create a separate table for customer name. So in case of any frequent updates, we'll go and update in the master table. The transaction table will not get impacted. These are the only performance techniques which all the SQL developers will use. Other than that, there is nothing else. These are the only 4 topics. Anything, if somebody is questioning on performance, it will be in these 4 topics only. They'll just give you some use case and ask, what you will do. These are the 4 things. Okay. Now we have done with the 2 types of indexes: clustered index, non-clustered index. You know how to compare, how to save your execution plan. That's it. Now you also learned about how to drop an index. You just use drop index. Make sure give table name dot your index name. If you don't want to remember that, you can right click and delete. Okay, we deleted everything. Huh? Let's go ahead and create one. Okay. If you want to delete it, right click and there is an option called delete. Right click. If you want to rename, there is the same option available here, rename. You can use that same method which we were renaming for tables also. Execute sp_rename. Current name, comma, new name, comma, n hyphen index. Which means you are trying to tell to that SP that you are trying to rename the class. So if you feel this is very difficult, you can do it by right clicking on that. Okay.
This is to rename the index, Java?
Yes, yes.
Okay.
Old name and new name. Okay. We need to specify the table name also. You can see here. And got rename. Same thing, if you don't remember the syntax, you just simply go here and give whatever name. So we learned about how to rename the index, how to drop index, how to create an index. And there is something called disable, which means for time being, you don't want to create an index, you can go ahead and disable it. How do you disable it? You can just right click and there's an option called disable. Index will not get deleted. it won't work. It will be disabled for now. Why do we need to disable it? Frequent updates. Example, you inserted a product called Apple. Inside one more product called iPhone, let's say 7 Pro Max. Now pages are already created, na, backend mein, for that index. This iPhone gets created in the last page, but as per iPhone I goes to some page which belongs to I. So you want to reshuffle and bring it back. So what you have to do is right click and there's an option called rebuild. Okay, there is no enable here. Remember, rebuild is enabling it. Disable and rebuild. So what it will do is, जो भी create किया था, shuffle हो गया था, new data, old data, it takes and rebuild everything back to its order. We know create, delete, rename, disable, rebuild. There is something called reorganize. Reorganize is the one which I was talking about. Na I is last page में उठा के first page में डालना है, तो reorganize. Rebuild is nothing but enable. Disable मतलब as the word says disable. Reorganize means वो shuffle हुआ हुआ data को you bring it back to its original page. Now there is only one topic which is pending on the index, which is called as another filtered index. Now as the word says filtered index, you will create index on a subset of data. What exactly is the subset of data? I'll show you an example. This is also a non-clustered index only. What I'm saying is create an index on this sample superstore data for the sales column only for a condition wherever the sales is greater than 1000. For that you create an index. That is why it is called as filtered index. So if I query this, first I'll do what I'll do is I'll go ahead and delete this existing one. And now I'll create one filtered index. Filtered index. Now index is created. Now let's go ahead and write one query. Select star from. That index is created. Okay. Select star from superstore where sales less than 9000 for an example. Okay. इसका execution plan देखते हैं पहले. I'll go ahead and click on execute. It's a table scan. You created one index on the superstore table for sales, but look at here, it is using table scan because your condition is what? Less than 900. Now what I will do is greater than 1000. We'll do is superstore. You can see here automatically it has taken non-clustered. So I'm trying to query wherever the sales is 2314. Instead of table scan, it automatically goes and does non-clustered. In case I generally don't use filtered index, but in case if there is a requirement, remember that there is something called filtered index. It is again non-clustered index only, just that you are putting down some filtering condition. Okay? And one of the good use case of this is if you work with the tools called Workday or any enterprise reporting tool, na, backend mein, Workday is one solution where they'll keep only one database for all the companies. Example, ITC and they say, let's take one more company called Capgemini. Both these companies are using a tool called Workday. तो ये लोग क्या करते हैं, एक ही डेटाबेस होता है, उस डेटाबेस में कॉलम होता है org करके. So org here for this company is ITC and for this one is Capgemini. तो वो लिख देगा कि बोलेगा Capgemini वाला I am not getting good results, तो वो लगा देगा filter where org is equal to ITC लगा देगा, sorry, Capgemini लगा देगा. So whenever this Capgemini go, he may see some performance improvement. Okay, got it? One of the use case of this. That is also one business model. Really, I'm saying. You are saying, looking at this number, right? You might think, okay, operator cost है, IO cost है, CPU cost है, उससे क्या फर्क पड़ने वाला है? Yeah, 10x improvement है, so what? मेरा laptop है, होने दो CPU use, है ना? Now, this entire SQL is also available called Azure SQL. Everything is same. It's available by Azure. आपको SQL install करने का जरूरत नहीं है. Azure will automatically install everything for you. All you have to do is just connect to SSMS, and when you are giving here credentials, you'll give your Azure ka IP address. So backend में your company, what it has done is, instead of managing this entire SQL by their own IT team, वो सब निकालने के लिए what they did, they purchased one subscription from Azure. They got that same SQL server from Azure. Now Azure का pricing model देखोगे, Azure will say, you go ahead and store 1 GB of data, don't pay me anything. You go ahead and store 1 GB of data, don't pay me anything. Pay me per query. This is the pricing model of Azure. You run one query, you pay for it. How do you pay for it? The data. अभी कोई उल्लू का पट्टा होगा जिसमें 5 million records होगा, वो मारेगा execute. तो वो पे करेगा उसके लिए. This is the pricing strategy. Now that pricing strategy, I'm just taking one example where 5 million records is there. Your select query is returning 5 million, pay for it. Along with that, whatever the CPU cost, memory cost, you have to pay for it. Is query ka, whatever is the CPU memory, you pay for it. Okay. That is the reason I went and I explained you all these things so that you know the importance of index. You know what is root node, what is leaf node, and what is clustered, not clustered. Because when you work in this kind of environment, you will become a guy like he knows everything here. So this guy is someone who knows the best practices of SQL. So you'll get a good visibility. So you don't have to worry around. I know how to create index, but somebody asks, what exactly is clustered index? Why don't you create non-clustered? You should know the difference between those. Okay? So those are the topics related to index. So that's it. There is nothing else on the index. Any doubts?
Javed, we pretty much understood as to what are the significance of, executing this index. But on a real-time instance, like
Okay.
let's say we work on a project or for an organization and they have a huge database, how do we particularly, bring this into place to toddle around with the information, Javed?
Okay. So what
Like
happens?
we understood the optimization part and everything.
Yeah.
I mean, we clearly got it, but
Okay.
just wanted to know how beneficial or helpful is this?
So I'll tell you, right, to answer that question, first thing is, if you want to talk about these concepts, first thing is, are we the right person in that project? If my role is, example, I'm a visualization guy, all I can do is, I am facing issues on performance. Can somebody go in and optimize it? There would be a DBA team who will do it for you. All you have to do is just say that there's a performance issue. Option one is that. Option two is where your team itself is everything. Your team, there is a division key. You take care of Tableau, but you also have another team member who takes care of this DB part of it. You tell him that go ahead and create a clustered index, non-clustered index on these columns. How do you say these columns? You are the one who is writing queries. You know that you are trying to query all on product name, order date. Give those column names to him. Let him go and create it. The last option is where you are the one-man army, where you have read-write access to that database. Only then you can create it. Now, what I have seen generally is chances are 50-50. If you're working in client environment or any project, they may not give you write access. They may give you access to create index, but they may not give you access to create tables. If you have access, you can go ahead and create it. First, create it for some sample records, test it out, then go ahead and please note, whenever you create index, it is not necessary कि every time your clustered index is getting used. SQL का जो memory engine है, backend में DB engine, it's super smart. For an example, if I write this query, where was it? We were writing one query called sales greater than 1,000. and it was still doing table scan. SQL is the best guide to know when to use a clustered scan, when to not use a clustered scan based on your SQL query. Aisa nahi ki you created a index and every time it is going to use it. It will check your query. If that query is relevant and it requires that cluster, only then it will use it. Sometimes you may get worry ki I to created cluster, but in execution plan, why is it not showing? Because your query doesn't require an index, so hence it is not using it.
Oh, got it.
Okay.
Okay.
Now we'll just finish our session with the rank function. Yesterday we left out the rank function, right? So first we'll query that sample superstore. Sample superstore means, let's say for subcategory ka, we are trying to print what is the total sales. We'll do group by subcategory. This is my sales. I'll rename this column as total sales. Let's do order by sum of sales in descending order. This is the chairs is the highest. I want to assign a rank. How do you assign a rank? So we have a built-in function called rank. Rank over order by sum of sales. I'll explain what exactly is this. Okay. How do you write a rank function? First, you need to call rank over. Over means on which particular column. So you want to give a column called sum of sales, no? But sum of sales, you can, how do you want to rank it? By descending order, ascending order, you have to specify order by sum of sales in descending order, as is the column name. Now, if you look at it, automatically it has started from rank 1. We have 17 products, 17. Yeah.
And Javed, after the rank function there, no? May I know why the blankets, I mean the brackets are empty there,
Yeah, this is a function like we call sum function now.
right?
So generally we call rank function and there is no parameters in the rank function.
Okay.
Parameter is after the rank function. So this
Oh.
is syntax how the SQL recommends. I think it's the same with MySQL also, but more or less all the SQL engines, this is how we call it actually.
Okay, thank you.
Okay. Clear? Any doubts? I'll share you this. Views we have already covered. Rest we have all covered. I think we have only few topics left out. These are very simple topics, no complicated ones. Okay, very easy to understand. Also, we don't use this a lot generally as data, but good to know. Okay. So go ahead and practice this. You already have Superstore. Make sure you save your execution plans. You do it by yourself. You write that statement, do it so that you will remember it forever. Okay. So thank you for joining. Let's meet next week.
Thank you, Javed.
Thank you. Have a nice day.
Thanks, bro. Bye.